In the next 5 seconds, the equivalent of a soccer field of soil would have been eroded globally. And guess what? It could take up to 1,000 years to create just 3 centimeters of topsoil. The importance of soil becomes even more relevant when we realize that soil erosion is directly linked to hunger and starvation, land degradation, landslides, floods, and water pollution. And none of us here is spared any of these consequences, and it only gets worse with climate change. Indeed, we're carelessly losing an invaluable resource from under our feet and under our watch. The wall that I have come to break cuts deep into the ground. It's at the foundation of several walls being broken here today. But I propose to shatter it using mushrooms. Yes, mushrooms. See, soil erosion occurs when the impact of water and wind causes the detachment, the transportation, deposition, or translocation of soil particles. The solution is to improve the soil properties to resist these erosive forces. So typically, engineers use cement, concrete, and other chemicals which are strong and reliable, but whose production and installation processes are costly. They disturb and damage the ground, but more importantly, they contribute to carbon emissions, which cause global warming and climate change. And so better alternatives are urgently needed, like the natural mushrooms. Did you know that 3/4 of the total microbial biomass in the soil is fungi? And that a single species of fungus is the world's largest and oldest organism, occupying an area that is 20 times as large as the Vatican City. Mushroom is fungus, and the roots of mushroom called mycelium can form vast 3-dimensional networks in soils and release natural chemicals which have significant implications for soil engineering. At a laboratory scale, we have developed methods and optimized conditions to grow the mycelium of oyster mushroom in soil, specifically in sands, in order to use its unique properties to improve the hydraulic and mechanical properties of the soil. And we have tested this for soil erosion by simulating typical erosive forces and comparing the volume of soil loss with or without mycelium grown in them. Up to 80% reduction in soil loss has been achieved. This is unprecedented and is very promising. If a single species of fungus could achieve this, imagine what we could do with thousands of other species in erosion-prone areas across the world, from Australia to Africa and up to Europe here. In the last 2.5 minutes since I've stood here, that's over 30 soccer fields of soil already eroded. And we need to take action immediately. This is beyond tolerable limits. So.